Battle of Technologies, SkyWay versus tram. We continue our series of publications comparing existing modes of transport with the innovative SkyWay transport systems. In the debut issue, we discussed the monorail, and today we will talk about the tram, one of the oldest public transport means. How practice shows, it's quite difficult to find a worthy alternative to tram. Judge for yourself. Good passenger capacity, relatively low operating costs, environmental friendliness, and a dedicated line for traffic. It would seem to be the ideal solution for urban transport. But this all is not that simple. In addition to the obvious advantages of using trams, there are no less significant minuses. Let's look into it. One of the first. History of modern tram originates in the 30s of 19th century. At that time, the precursors of trams, so-called horse cars, began to appear in the cities. A horse car was a city railway, the carriages of which were driven by draught animals, most often horses, although there were mules and even zebras. American cities such as Baltimore, 1828, New York, 1832, and New Orleans, 1835, pioneered the introduction of horse cars. However, horse-drawn railways became really popular thanks to the French inventor Alphonse Lebot, who in 1852 proposed the idea of a railway rail with a gutter for a wheel flange. Rails of this design could be sunk into the roadway, which eliminated the most important drawback of horse cars: rails protruding by 15 kilometers, which caused a lot of inconvenience to other road users. In fact, Lebot rails are still in use today. As opposed to the omnibus, which is a multi-seat horse-drawn carriage moving on a usual road, the lower rolling resistance of the steel wheel on the rail allowed the horse to move the heavier carriage. However, like its predecessor, the horse car was not devoid of another disadvantage, an example, the horse. The physical capabilities of the animals affected the mode of operation of the passenger line. The walking day of the horse is 5 to 6 hours, plus such an engine required care and nutrition. If we take into account that on average there were about a dozen horses per carriage, the cost of the maintenance was quite serious. Therefore, it was only a matter of time before the engine was installed in the tram. In 1914, in New York City, the horse car was abolished, and it was replaced by an electric tram that we know well. The same trend was witnessed in other cities around the world. To date, the only operating horse car is the British Douglas horse tram, which is located in the island's capital, Man. Each and every one has its own way. One of the key advantages of a tram line is a dedicated line for movement that allows it to travel in urban traffic at a higher average speed than, for example, a bus or trolleybus carrying much more passengers. But you can only realize the full potential of a separate line if it is completely isolated from other road users and pedestrians. In practice, this is quite difficult to achieve, especially if the tram lines run through residential buildings. Therefore, a tram can be stuck in the traffic jam, and an accident involving it can completely paralyze the traffic on a separate section. In the string transport complexes, the rolling stock moves on the track structure, which is located above the ground surface on the second level. This solution eliminates the full range of problems that can result from being in a close proximity with other road users. Everything is simple: no accidents, traffic jams, and the speed of the rolling stock is unlimited, and a great view outside is a bonus. By the way, the townspeople are very loyal to the tram. Why? It's a rhetorical question. Most likely it's because of the opportunity to ride a mini train in the city without going down under the ground. But even in this purely aesthetic question, the string transport is a win-win situation, offering the urban dweller a unique opportunity to try on an electric car that travels on air rails. Who's behind the helm? The tram is driven by a driver, a tram driver, with all the resulting potential problems, including those related to safety. Because of the human factor, any system will remain vulnerable because no one is safe from errors. A pedestrian can incidentally run out on the tram line. An inattentive driver didn't give away and the tram didn't have time to slow down. The result is downtime on the line, financial losses to the transporter and the affected parties. And it's a relief if the victims have suffered purely material losses. Attempts to automate the city tram are being made. In September 2018, within the framework of the international exhibition InnoTrans in Berlin, Siemens held a demonstration of the Combino tram, which transported passengers on a 6-kilometer line in Potsdam. The tram was provided with equipment that is used in unmanned cars, cameras, LiDAR and radar, which work in conjunction with the software. The successful introduction of autonomous trams can significantly improve the safety of these vehicles. However, as long as it is on the same level as the other traffic participants, the threat will remain quite significant. The rolling stock in the SkyWay transport and infrastructure complexes is already fully automated today. Due to the location of the track structure on the second level, the absolute majority of possible obstacles to the rolling stock disappear. Consequently, the number of variables to be processed by the control system is reduced. That means that such a system can be made more reliable and efficient than existing analogs. Smart SkyWay vehicles not only can distinguish obstacles on their path, constantly monitor the safe interval between individual transport modals, but also automatically dock with the faulty modal and further tow it to the depot. The SkyWay rolling stock management system is already able to recognize faces, which allows it to monitor the deterioration of passenger health, as well as to detect and prevent illegal actions, such as vandalism. In addition, it is constantly self-learning, which means that the level of safety in the string transport systems will constantly grow. Speed and carrying capacity. Among all types of urban public transport, the tram is among the leaders in carrying capacity. Speed versions 22,000 passengers an hour, and rolling stock capacity second only to the subway. The number of carriages on the tram line can be easily increased by coupling without increasing the number of drivers. Modern trams can travel at speed of up to 120 km per hour, but in practice, however, their performance varies from 20 to 40 km per hour due to their location on the first level and constant traffic interruptions. That is again due to the fact that trams move on public roads. By the way, on the territory of the CIS, tram systems with an average operation speed about 24 km per hour are called high-speed ones. In the SkyWay urban transport systems, the carrying capacity can be 50,000 passengers per hour or more, and the maximum speed of the rolling stock can reach 150 km per hour or more. It is clear that it should be on straight lines, and for heavy variants of the urban complex, in which trains with a capacity of 200 to 300 passengers run, it is also obvious that if there are curves on the track with, say, a radius of 200 meters, the speed of the vehicle cannot be higher than 36 km per hour because of lateral centrifugal accelerations, which for physical reasons cannot be higher than 0.5 meters per second. And this is not a drawback of SkyWay. It is the laws of physics, which all transport systems are subject to, including string transport. As well as the developed speed of 150 km per hour cannot be developed if, for example, there are 500 meters between neighboring stations. Then the speed can be maximum 70 km per hour in the middle of the run, again based on the laws of physics, as the comfortable acceleration and braking should be less than 1 meter per second. Otherwise, for such comfort of urban transportation, there is a set expression: was transporting like firewood. Therefore, the carrying capacity of 50,000 passengers per hour and a speed of 150 kilometers per hour are the possibilities of urban string transport, and the specific characteristics of a particular urban transport line are determined by a feasibility study or a business plan for a specific target project. Some numbers. The tram has an impressive margin of efficiency, but the price of its entering the city remains quite high. It is a fact. The cost of construction of 1 kilometer of city tramway will cost on average about $10 million. However, these figures are rather tentative, as they do not take into account the cost of rolling stock, infrastructure, energy supply, and many other things, because they may vary depending on the specific location for construction. For example, the preliminary estimate of the project of the Moscow suburb, not Moscow, tram line from Podolsk to Yunitskiy via Domodedovo and Zhukovsky airports amounted to 92 to 98 billion Russian rubles for a 74 kilometers long section with 16 stations, and that's more than $20 million per kilometer, including infrastructure. In this case, as a rule, the most expensive part of any tram project, the cost of urban land, is not taken into account. But the high cost of building tram lines is justified by other advantages of this type of transport, an example durability, environmental friendliness, and low cost of travel. Unlike road transport, trams do not pollute the urban environment with the products of hydrocarbon combustion and wear and tear of pneumatic tires and asphalt, and its paths can be combined with green lawns, which also has a beneficial effect on the urban microclimate. Bus or trolley bus service life is 10 to 20 years, and for a tram, even 15 years is not a problem. In addition, recently, trams have been equipped with systems that convert the direct current supplied by the tram into alternate current. This has made it possible to install AC motors on the tram, which are virtually maintenance-free because they have neither wearing parts nor rubbing parts. Trams also boast a fairly low cost of travel, which is 40% lower than on buses or trolleybuses. We can't help mentioning the obvious drawback of the tram: noise and vibration. The maximum technical weight of the tram, with passengers, can reach 50 tons, which together with heavy metal wheel seat, uneven rails, and joints between them guarantees shaking of dishes in the kitchen cabinet of the city residents. The facades and foundations of the buildings are also affected. Of course, it can be partially corrected by installation of a vibro-insulating cloth, rubberized wheels, and thermic welding of rails in a weep, but it will not possible to completely get rid of branded tram rumble. The SkyWay transport systems are characterized by low material capacity. Thanks to string rails, the track structure can bear heavy loads while remaining light and durable. Low materials capacity means low construction cost. The SkyWay's rolling stock is fully electrified, so its environmental impact is virtually zero. The safety margin of the track structure is designed to operate for 100 years, of the rolling stock 25 years. The SkyWay rolling stock is provided with specially designed steel wheel motors. They are distinguished by their low rolling resistance due to the narrow in the rolling direction contact surface. Wheel motors in tandem with outstanding aerodynamic performance ensure low rolling stock energy consumption. The uncut overpass, the filling of strings rails with special concrete and the use of composite materials in the construction of motor wheels successfully solve the problem of noise generation in the string transport complexes. In the long run, the SkyWay's rolling stock is to become almost noiseless as work in this direction continues. Lower power consumption plus low capital costs of building the SkyWay transportation complexes together provide a low cost of travel for the passenger. According to calculations, the cost of a ticket on SkyWay city lines will be lower than that of possible competitors. Conclusions. The advantages of tram are largely offset by one key drawback: the need to share street space with other road users. Of course, the most problematic areas can be taken to a separate level, isolated overpass, or isolated underground line. But in this case, it is inevitable that the cost of construction will increase, which will call into question the expediency of their erection. String transport systems are free from the disadvantages of trams, even at the design level. High travel speeds, efficiency, unprecedented level of safety and comfort for passengers, low cost of construction, cost effectiveness. The advantages of SkyWay can be talked about for a long time, but even the listed ones are quite enough to draw a simple conclusion: a credible alternative to existing modes of transport is already in place.